Hey guys, welcome again to the Maths Club. So we're continuing on the playlist that we started a while ago on algebraic processes, and we're going to be looking at simple operations on algebraic expressions. Without further ado, let's get started. So the first operation we're going to be looking at is expansion. Algebraic expansion is like unpacking and arranging parts of a mathematical expression to make it simpler. So you have something, you're unpacking it, that means you're removing it from the carton, from the brackets, and then once you remove from the brackets, you now try to rearrange everything to make it look simpler. So it simply means opening of brackets. So there are three different methods that we use to expand, and we'll look at each of them step by step. The first one says if you have an algebraic expression a plus b in brackets times c plus d, there is a way you can be able to open it, and I'm going to actually write it out so that we are all following. So we had a plus b multiplying c plus d. So the first things first is that this c plus d, we can repeat it 2 times and say c plus d in brackets and then c plus d in brackets. I repeated this c plus d 2 times. Please take note of this because it's going to come in very handy even ahead. Now the first of the operands, which is a plus b, I will now split it across this. So the first guy is a and the second guy is plus b, so I'll just say plus b. All we did is that we splitted this c plus d, the second operand, we put it 2 times, then we wrapped the first one with the first guy from the first operand, and then the second of the repetition with the second guy from the first operand. So c plus d 2 times a and plus b. So that means that if I have this, I can also be able to get back this, and if I have c plus d in brackets, I can pick one of them, which is a plus b in brackets, and pick one of the repetitions, c plus d. This will come in very handy. A times c is ac plus a times d is ad, plus b times c is plus bc, and plus b times plus d is plus bd. Simple and short. Repeat this guy 2 times, then wrap all these guys around it, a and then the plus b. In this second method, we repeated the second guy here, so you see c plus d, but this time around we're repeating the first guy. So let's see it. So to add a bit of complexity to it, just small, I just use the minus instead of a plus. So I'm repeating the first guy. So this is a plus b and this is a plus b. So the second guy is to the right of the first guy, so we'll just maintain that. So this is the first guy is c, so this one multiplied by c plus, and then we're left to minus d, so I'll put the minus d here after the second repetition. So a times c is ac, b times c is plus bc, plus a times minus d, that is minus ad, plus b times minus d, that is minus bd. So this is how we can open the bracket. So this is c. This is the second method, and we can see, so we repeated the a plus b 2 times, the c we brought it to the right and the minus d to the right, because if you notice the a plus b is the first guy and it's to the left of the second. That's why you can see we put this guy to the left and this guy to the left, but this one is to the right and we're repeating the guy at the left. So repeat, right. So when you're done with that, you'll be left with ac plus bc minus ad minus bd. Now the third method, which is the method that most of us are actually used to, is the FOIL method. So we have the FOIL. If this is a description, we can agree that if this is like a fence around it, the F is saying that multiply the 2 first guys in the bracket. So I'll be multiplying these 2 guys, right? This will give me AC. It now says multiply the outer guys. So if you look at this fence, this is the outside of the fence to the left, and this is the outside of the fence to the right. So I'll multiply the 2 guys that are outside. So this is A and D. So this is AD. Then I'll multiply the guys that are inside. So that these are the guys that are inside, the B and C. B and C are the ones inside. This will give me BC. Then the last is multiply the last guys. So if you look at the last guys inside the brackets, these are the 2 last guys. So this B, D. Well, this might not be familiar to you, but this is what you have actually been doing. So what we'll do is that we'll just say A plus B, C plus D. Then we'll say A times C, which is AC. We'll say A times D plus AD. Then B times C, we say plus BC, then B times D, which is plus BD. This is actually what we've been doing since, because after you do the FOIL, you now add all of them together. This is actually it. So we've talked about the 3 methods. First method is that you repeat the second guy, then you spread over the first guy. The second method is that you repeat the first guy and spread over the second guy. And then the third one is using the FOIL method. Let's look at an example. So this example says that we should expand 2x minus 5, x minus 3. I want you to pause the video and try this out yourself. Welcome back. Let's solve it together. So I'm going to be using each of the methods for each of the examples. So the first method is we're repeating the second guy. So that would be x minus 3, x minus 3. And we're going to spread over the first guy. So the first is 2x, and then we're spreading the minus 5 to the second guy, because this first guy is to the left, so just maintain that position, left, left. 2x times x is 2x squared. 2x times minus 3 is minus 6x. Minus 5 times x is minus 5x. Minus 5 times minus 3 is plus 15. So let's simplify it. So 2x squared minus 6x minus 5x will give me minus 11x plus 15. So that's basically it about it. If you got this, well done. Let's see if our answer is correct. So 2x squared minus 11x plus 15. Great. Second example says that we should expand x plus 3 and x plus 2. I want you to pause the video and try out this example using the second method. Welcome back. Let's solve it together. So in the second method, we repeat the first guy, which is x plus 3 and then x plus 3. Then we spread the second bracket. So the first is x, so this will multiply x. This will be x, and let me just put the plus here, and then we are multiplying it by 2. So x times x will give me x squared. 3 times x will give me plus 3x. Then plus 2 times x, which will give me 2x, plus 2 times 3, which will give me plus 6. So this is x squared plus 5x plus 6. Let's see if we're correct. Great. Third example says that expand and simplify the expression 2x plus 3, 4x minus 1, plus x minus 2, 3x plus 5. I want you to pause the video and use the third method to solve this. Welcome back. Let's solve it together. So we'll say 2x times 4x, that will give us 8x squared, and 2x minus 1, that will give us minus 2x. 3 times 4x, that will give us plus 12x, and 3 times minus 1, that will give me minus 3. So this is the first expansion. I'll put inside the brackets, plus second expression. X times 3x, this will give me 3x squared. X times 5, this will give me plus 5x. Minus 2 times 3x, this will give me minus 6x. Minus 2 times 5, this will give me minus 10. So before we go for that, let me just simplify the bracket. So this will be 8x squared minus 2x plus 12x, this will give me plus 10x minus 3 from this first guy, then plus open brackets 3x plus 5x minus 6x, this will give me minus x minus 10. Right? So I can expand the brackets, but fortunately for us, this is plus, and plus times anything does not change any of the signs. That's why it's always good to put inside brackets. So it's minus will have changed the sign. So this is meant to be squared. 8x squared plus 3x squared is going to be 11x squared. 10x minus x, this will give me plus 9x, and then minus 3 minus 10, this will give me minus 13. So this is our answer from simplifying this expression. Let's see if we are correct. 7x squared plus 9x minus 13. Great. So we're moving to coefficients of terms in expansion. So the coefficient of a term is the numerical factor that is multiplied by the variable. What does that mean? So if I have 3x squared, the coefficient is not the numerical factor, which is the number in this case, which is what? 3. So the coefficient of x squared is 3 in this case. Coefficient helps us to determine the magnitude of each term in the expansion, that is how large the term is. So they provide information about the relative importance of different terms in the expression. So the higher the coefficient, the more important that term is. Term is like this entire thing, 3x squared. So if the highest coefficient of, maybe it was 3x squared plus x plus 1, and of course the one that has x squared that is multiplied by 3 is the most important. It's the one that the end product, like how the value will be like, will be determined by. Because if the x is, let's say 2 times 2 is 4, 4 times 3 is 12, right? So if it's plus x plus 1, you can see that those other ones, plus x is just 2, plus 1 is just 1. You can see that the bulk of the answer, which is I think 12 plus 2 plus 1, that is 15, really came from the 3x squared, that 12. So you show you how important it is in the expression. Let's see some examples. So in this example, it says find the coefficient of x in the expansion 4x squared plus 3x minus 1, 3x plus 1. So you can use any method that you want. Welcome back. Let's solve it together. So to solve this, I think it's best I just use my, okay, let me use the second method. So I'll repeat first guy, which is 4x squared plus 3x minus 1, and this will be 4x squared plus 3x minus 1, and then I'll spread over the second guy. So because it's to the right, so that'll be 3x then plus this guy, so this guy will multiply 1. So 4x squared times 3x, this will give me 12x cubed. 3x times 3x, this will give me plus 9x squared. Minus 1 times 3, this will give me minus 3x. So that's from the first guy. Expand second bracket, since it's just times 1, it will be the same thing. So that will be plus 4x squared plus 3x minus 1. Unfortunately for us, since what we're using to expand the brackets is plus, none of these signs will change. So I can just go ahead and add. So this will be 12x cubed. There's nothing else like 12x cubed. So that will be 12x cubed plus 9x squared plus 4x squared. This will give me plus 13x squared. Then so we have minus 3x plus 3x. So that will cancel out. Then we have minus 1. So it says, what is the coefficient of x in the expansion? So is there any x here? No. So that means coefficient is 0. So therefore, coefficient of x is 0. Let's see if the answer is correct. Great. So this example says that what is the coefficient of AB in the expression a minus 4b, 2a plus 3b? I want you to pause the video and try this out yourself. Welcome back. Let's solve it together. For this one now, I'm going to use the first method. So that means I'll be spreading over the second guy. So that will be 2a plus 3b and then 2a plus 3b. And in between them, I'm going to put the first guy, which is a, second guy, which is minus 4b. This 8 times 2a, this give me 2a squared. 8 times 3b, this give me plus 3ab. Minus 4b times 2a, this give me minus 8ab. Then minus 4b plus 3b, this give me minus 12b squared. So let's rearrange and put all these squares first. So this will be 2a squared minus 12b squared. Then 3ab minus 8ab, this will give me minus 5ab. So therefore, the coefficient of AB in this expression is going to be minus 5. Let's see if our answer is correct. Great. Next thing I'm going to talk about is factorization. And factorization, if you remember when we were doing factorization, if you can remember, you click on the video that will appear at the top right. We said something. If I wanted to find the factors of 6, what are factors of 6? That can multiply 6. Or if I divide 6 by that particular number, it will give me a whole number without repetition. So we said we'll say maybe 1,6, 2,3. Then by the time I say 3, I'll be like repeating myself, so I'll stop there. So 1 is a factor of 6, 6 is a factor of 6, 2 is a factor of 6, 3 is a factor of 6. So it's the same concept. So when we're talking about factorization, we're saying we have a variable. We have something like maybe x plus 3 is multiplying x minus 2. We want to see what are the things that I can divide that will give me a whole number. So this one, you can agree with me that I can divide it by x plus 3. It will give me x minus 2. I can also divide it by x minus 2. It will give me x plus 3 in that case. So it's just the same concept here, but just that we're dealing with algebra. So factorization is a method of expressing mathematical expression as a product of its factors. So a factor is a number or algebraic expression that divides another number or expression without leaving a remainder. We've talked about that. Factorization is the reverse of expansion. Expansion is that you have things in brackets, you're trying to make them look simpler. But in factorization, you have the simpler version, you are trying to put them inside brackets. The process of factorization involves factoring out a common factor from a given expression. So we'll see all of this in practice. Example 6 states that factorize ab squared c cubed minus a squared bc squared. Let's solve this together. The process of factorization involves factoring out a common factor from a given expression. So this is the expression that we have. What is the common thing? There is a here. There is a, because this is a squared, so one of them is a. There is b squared, but there's only one b, so a is common, b is common. There is c cubed, there is c squared, so c squared is also common. So if I divide ab, so ab squared c3 by abc squared, this will cancel 2 of these guys, so it's only one. This will cancel 1 of this guy, this will cancel this guy, so we'll be left with bc minus, and if I say a squared bc squared divided by abc squared, this will cancel this, this will cancel this, this will cancel one of them, so I'll be left with a. So therefore I could just say that in terms of factor, you know what we were saying, that we're trying to put them inside brackets. So this is one bracket and these are another brackets. So our answer is abc squared in one bracket and bc minus a in another bracket. This is as simple as it gets. Let's see if we are correct. So abc squared bc minus a in another bracket. Example 7 states that we have 2x open bracket x plus 2 plus 3 open bracket x plus 2. I want to factorize it. That means putting it inside 2 different brackets. I want you to pause the video and try this out yourself. Welcome back. Let's solve it together. Remember our first method. We said if we had a plus b multiplying c plus d, that we could repeat the first guy, which is c plus d, and c plus d, and then spread over the first guy, which is a then plus b. Remember when we did this? So the same thing too applies here. You have x plus 2, x plus 2, x plus 2, x plus 2. So let's say that is the second guy, x plus 2. Then you just put the first guy, which is 2x plus 3, in its brackets, and you're good to go. This is the answer for this particular question. So if you do something longer than this, well, let's see if you're correct. So 2x plus 3, x plus 2. Very simple. Another example says that we should factorize m open brackets 2a minus b minus 2n open brackets b minus 2a. Pause the video and try this out yourself. Come back, let's solve it together. It takes almost the same shape as the previous guy, just that this is 2a minus b and this one is b minus 2a. So the b is negative here, the b is positive here, the 2a is positive here, the 2a is negative here. So if I factor out minus from this, what do I mean? I have m open brackets 2a minus b. So if I say minus 2n and I factor out another minus again, so let's just say minus 2n times minus open bracket. So if I factor out minus, all of these guys will change. So this minus 2a will turn to plus 2a, so 2a, and this b will turn to minus b. So what you just do, I just factor out minus to change the signs. If you factor out minus, you're good to go. So this will be m open brackets 2a minus b minus 2n times minus, that will give you plus 2n open brackets 2a minus b. So you're good to go. Now your answer is just m plus 2n open brackets 2a minus b. Simple and short. The first thing is that you have to first check, I did the same thing, not the same thing. Change the sign of what is outside. So if it's minus, it will be plus, then you can swap the values. As far as it's like one is negative here, one is positive, one is positive here, one is negative. If it was negative b, negative 2a, you can't do that too. Because if you factor out minus, that will give you 2a plus b, which is not the same thing as what you have here. So you have to be very, very careful. So let's see if our answer is correct. 2a minus b and m plus 2n. Great. This example says that we should factorize 3x open brackets 4 minus y minus m open brackets y minus 4. Close the brackets. Pause the video and try this out yourself. Welcome back. Let's solve it together. It's the same thing. 4 here is positive, 4 here is negative. Y here is negative, y here is positive. So I'll just say factor out minus from second bracket. If I do that, that will be 3x 4 minus y minus m times minus open brackets. I could just say 4 minus y now, since I've already factored out the minus. So that will be 3x 4 minus y. Minus as minus is plus, that will be plus m open brackets 4 minus y. So let's put this inside brackets. This will be 3x plus m, then 4 minus y. Simple and short. Let's see if we're correct. X plus m, 4 minus y. Great. This leads us to difference of two squares. When you have difference of two squares, it just tells me that there's something that is a square. There's also something again that is a square and a minus in it. So difference of two squares is a mathematical concept that arises when you subtract one perfect square from another. What are perfect squares? Perfect squares are numbers that are resulting from multiplying an integer by itself. So if you have minus 2 times minus 2 will give you 4. 2 times 2 will give you 4. 3 times 3 will give you 9. So you must multiply an integer, whether negative or positive, by itself. So if I have something like 4 over 9, 4 over 9 is not a perfect square because 4 over 9 is a fraction. It's a fraction, and that is a real number. But integers are whole numbers, whether negative or positive. So when you have two perfect squares, say a square and b square, the difference can be factored using a special algebraic identity called the difference of squares formula. It states that a squared minus b squared is equal to a plus b, a minus b in different brackets. Whenever you have something like this, a squared minus b squared, you can say a plus b, a minus b, and you'll be fine. Let's say I have 9 minus, okay, what else is it? Minus 4. 9 is 3 squared and 4 is 2 squared. So just to show you it's correct, I could say 3 minus 2 multiplying 3 plus 2. 3 minus 2 is 1 and 3 plus 2 is 5. 1 times 5 is 5. And that's something as saying 9 minus 4. So you can see that it checks out. Let's see an example. The example says that factorize 9x squared minus 4x squared. Remember, the same thing about factorization is that we're trying to find common factors, right? We're trying to find factors, just like we did 1,6, 2,3. We're trying to find factors. So let's solve this together. If you're given a question like this, first thing you want to see is, are all these guys, are they all squares? So can I find 9 as a perfect square? Yes, because 9 is 3 squared. So x is also a perfect square, which is x squared. Minus 4 is a perfect square, which is 2 squared. And they also have x squared. Since all of them are all square, 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 I can just say my answer is 3x minus 2x and then 3x plus 2x based on the difference of two squares formula. Let's see if the answer is correct. 3x minus 2x and 3x plus 2x. Great. Next example says that we should factorize x squared divided by 16 minus y squared divided by 9. This is taken from NECO 2003. I want you to pause the video and try it out yourself. Come back. Let's solve it together. Let's express each of them as perfect squares first. This is x squared all over 4 squared minus y squared all over 3 squared. Like I said, whenever I say factorize, always try to see if you can break it into perfect squares. So since all of them are square squared, this is like saying x over 4 all squared minus y over 3 all squared. Do you agree with me? Because if I have 2 squared x squared, it seems I'm saying 2x all squared. So if you have this is like saying x over 4 minus y over 3, close the bracket, and this is x over 4 plus y over 3, and I'll close the bracket. So this is basically it. Let's see if we're correct. Great. So x over 4 minus y over 3 and x over 4 plus y over 3. Next example is that we should factorize 27p squared x squared minus 48y squared, and it's taken from y 2004. I want you to pause the video and try this out yourself. Welcome back. Let's solve it together. The first is that, like we said, it involves factoring out what is common first. So what is common between 27 and 48? Let's see. So 3 is common. So we can factor out 3. What again is common between this px squared, x squared, y squared? Nothing else is common. So we can say 3. 27 divided by 3 is 9. So this will be 9p squared, x squared minus 40 divided by 3. That will give you 16. So 16y squared. Can you see something? Yes, you can see 9, 3 squared, square, square, 16, 4 squared, y squared. So this is like saying 3, open brackets, 3 squared, p squared, x squared minus 4 squared, y squared. So let me just recap this. So this is like 3 open brackets, 3px all squared minus 4y all squared, just to show that it's the same thing. So I mean, we already have this. So what do we say? We say 3 open brackets, let's open bracket, 3px minus 4y and then 3px plus 4y. Since there's already a difference of 2 square already, you can see it's square and a minus. As far as the difference of 2 square, we can use our formula. So our final answer is just 3 open brackets, 3px minus 4y and then 3px plus 4y. So this is basically it. Let's see if our answer is correct. So you see 3px minus 4y and 3px plus 4y. Next example says that the expression 4x squared minus 4 has the following as factors, except, I want you to pause the video and try this out yourself. Welcome back. Let's solve it together. So what to solve this? Remember we said that it involves factoring out what is common. So we can factor there's 4 here, there's 4 here. So we can factor that 4 and say this is like saying 4, this would be x squared minus 1. Can you see what I'm saying here? Yeah, so the first thing is that x squared minus 1 is a factor. So this option C is out of it. Now this x squared minus 1 can be written as 4 open brackets x squared minus 1 squared, because 1 squared is the same as 1. So we have 4 open brackets x minus 1, x plus 1. So if there's anything like x minus 1, x plus 1, it is out of it. Right, so we're left with these two guys. So because 4 is multiplying x minus 1 and is multiplying x plus 1, I could just pick out anyone and say, let 4 first multiply. Just like I'm saying, I have 3 times 2 times maybe times 4. I could solve it and say 3 times 2, which is 6, times 4. Is it the same thing? To give me the same answer. Right, so I could say 3 times 2 times 4, 8. Is it the same thing? So I could multiply these two guys. This is like saying 4 times x, which is 4x, minus 4 times 1, which is 4. Then open bracket x plus 1. Still the same thing. So if I close this bracket, so is there any of them that is an option? Yes, that is option E. So our answer is option D. Option D is the one that is not a factor. If it was meant to be a factor, that would be 4 times x plus 1, which would be 4x plus 4, not 4x plus 1. So these are how you solve questions like this in the exam. Let's see if our answer is correct. Option D. Great. Finally, we're looking at binary operations. What does binary mean? Bi means 2. right? So binary operation involves combining two elements to produce a single result. In a set X, binary operations like addition, subtraction, multiplication, divisions are performed on pairs of elements A and B. The results of these operations on A and B is another element within the set X. So what are they saying? So if I have 3 is an integer, and I say 3 plus 2. 3 plus 2 is going to give me 5. Is 5 also an integer? Yes. So in this binary operation, as far as all of them, like the two guys I'm adding together, they must all belong to the same set. So they must all belong to the same set. I cannot say 3 plus, maybe say the set X is a set of integers. I will not say 3 plus 2 over 3. Of course, this is going to give me a fraction. And a fraction is not a set of integers, but it's a set of real numbers. If all these real numbers, integers are not striking a chord, you might want to check the video up here at the top right, where we discuss type of numbers, integers, real numbers, and all of that. So if it was a set of real numbers, this could have passed because 3 is a real number, 2 over 3 is a real number, and the results also be a real number. We can say that thus the binary operation can be defined as an operation star, which is performed on a set X, where set X could be set of real numbers, could be set of integers, could be set of anything. The function is given by, so when you say we are doing the operation X such that an element of set X is operating on that element of set X to produce an element of set X. I know some of these things are looking confusing, but don't worry, with examples it will become very clear. Example 14 says that the binary operation star is such that an element of R operates on an element of R to produce an element of set R. Is defined as A star B is equal to 2A plus B. Then the value of 2 times 3 or 2 star 3 is, this R is not arrow, it's symbolizing real numbers. Remember we said we symbolize real numbers with R. As the case, let's solve this together. So we're given that A asterisk B is equal to 2A plus B. We're not told to find 2 asterisk 3. So A is standing for 2, B is standing for 3. I'll just substitute. So that will be 2 times 2 plus 3. 2 times 2 is 4 plus 3, which is equal to 7. So our answer here is 7. So in this example says that the binary operation star such that a real number is multiplying a real number to produce a real number is defined as A star B is equal to 2A plus B minus AB. Determine the value of 2 star 3 in brackets star 4. I want you to pause the video and try this out yourself. Welcome back. Let's solve it together. So just like we know in board maths, the bracket takes precedence, so we'll solve this one first. So that will be 2 star 3. 2 star 3, and we're told that A star B is this. So this will be 2 times 2 plus B is 3 minus 2 times 3. So anywhere we see A, we put 2. Anywhere we see B, we put 3. 2 times 2 is 4 plus 3, then minus 6. So 7 minus 6 is 1. So when we resolve this, we add 1. So that will be 1 star 4. We can now say 1 star 4 now. 1 star 4 will be, anywhere we see A, we put 1. Anywhere we see B, we put 4. So this is 2 times 1 plus 4 minus 1 times 4. 2 times 1 is 2 plus 4 minus 4. 2 plus 4 is 6. 6 minus 4 is 2. So our answer at the end of the day, so we can say therefore 2 star 3 star 4 is equal to 2. So these are we solve questions like this. Let's see if our answer is correct. 2. Great. And with this, we've come to the end of this particular video. If you found the video useful or you enjoyed what you saw, please like the video, subscribe to our channel if you have not, and if you know somebody that this channel can help, please share the link to the channel with the person. I'll see you guys in the next video. Bye for now.